Good morning, everybody. So let us start our lecture today. And today is September 14th. So let us see our schedule first. So this is our schedule. So according to our schedule, we have started our 5th week. And this week we will discuss linked list. You know, there is a test. Test 1 will be next week. Okay. So test 1 will cover from chapter 1 to chapter 5 up to linked list. Okay, the test will be next week during the class time. Okay, so during the class time. So next, I will decide by tomorrow when the test will be, either on Tuesday, hopefully Thursday. Okay. During class time, you will take the test in D12. Okay, during class time. So next Thursday. Today is Tuesday, and day after tomorrow is Thursday, and next Thursday will be your test 1. And test 1 will cover from chapter 1 to chapter 5. Okay. So today we will start chapter 5. So chapter 5 is kind of is seems to be difficult and maybe something new. But as you have taken 1322 CS2, you should be familiar with linked list. And then we will see that many of you may be familiar with implementing linked list with Java or C Sharp. Java and C Sharp, these programming languages do not have pointer. Actually, linked list is implemented with pointer. So if you understand linked list, how to implement a linked list, how to insert a data in a linked list, and how to delete data from a linked list, then you will have more experience of using pointer. Okay. So in previous week we discussed that pointer is a variable that contains address of another variable, right? Pointer is a special kind of variable. It does not contain any value, any traditional value that the traditional variables contain. Pointers contain address of another variable. Okay. So as we know that in a memory location, in a single memory location, only one variable can, only one value can exist. So if we know the address of a memory location, then if we can retrieve the content of that memory location, then we can find the value of that variable. So that is actually an indirect way of retrieving values using pointer. Okay, so we will see the use of pointer in the chapter. So the linked list. So if you go to your book, you will see that chapter 5 is linked list. So if you go through this, if you understand this chapter, then you will be able to design, implement, and test function to manipulate nodes in a linked list. We will come up with node. What is node? Is an object in a linked list. Will come soon, including inserting a new node, removing a node, searching a node, or other thing like copying. Okay, this kind of operation. Okay, so so you should read the book. Okay, so please, everybody has a copy of this book. You got your book? Okay. You need to collect books on, okay, and then you need to read it. Okay. Okay, so linked list. You see the linked list, you see that the picture on the right side. Linked list is the chain. It's a kind of chain, okay? Chain that we know that as usual chain, like a ring or chain, is a chain is made of some rings, right? So there's one ring is connected with another ring, 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 is connected with another ring. Okay, so we know that a ring, they are connected both sides. So this is kind of ring we are familiar with, right? So each ring is connected with another ring. For instance, if we say that this is the beginning of our ring or chain, and this is the end of our chain. Okay, so that every chain has multiple rings, so that each ring is connected with another ring. So each ring is connected with another ring, each ring is connected with the last ring is not connected with anything. So this is the last ring, okay, it is not connected with another ring. So it may happen that this ring can be connected with the beginning, the end, ring. That is called, we call circular linked list. Okay, that is a special linked list, circular linked list. We are not discussing circular linked list in this in this chapter. We are just discussing a traditional linked list. So linked list is the foundation of many other data structures. For instance, if you understand linked list, then you will understand stack, queue, okay. Especially stack and queue, you will understand easily if you understand linked list. But if you do not understand linked list, you will get trouble in understanding stack and queue. Okay, so in order to understand some other data structures and like recursion and other things, okay, so you need to understand linked list. So please give attention. Okay, as I was discussing that a linked list is a traditional chain. Okay, this is so each chain, for instance, so a chain is composed with some rings. So each ring, so additionally, for instance, each ring has two parts. First part, it contains data, and the second part is contains address, of the next ring. So here, instead of calling ring, we will call them as a node. Okay. Give me 1 second, please. Let me get my stylus. Okay, so here this is a node. Okay, so each node contains two things: data and address of the next node. Let's change the thickness. Okay, so here are the chains. So for instance, it is node need to be like this. It can be like, you can present like this way and things like this way. Okay, so for instance, not this. Okay, so each node, whatever is your node is, contains two parts. This part is data, another part is address. Okay, so we know that in order to hold address, we need to use pointer, right? We need to use pointer variable. Okay, so here on the right side, you see that this is a linked list. So this is a node. So this is a node. This is a node. This is a node, and its data value is 12.1, and this is the another. So another value. It holds the address of next node. So then it points to the next node. It knows who is the next element in this linked list, and then this way, this node it is connected to with this one. Okay, so data type, data can be any valid data type, but address must be a pointer type. Okay, and this is where it is going, and at the end of the linked list, if this is the last node, then it says end marker, end symbol, that usually it can be null, for instance, null. Okay, so this is how a linked list looks like, but internally we will not be able to see the structure in our computer memory. We need to imagine this. We need to imagine this, that we have a data structure in our computer memory, in our program, to a program. In a program, we are using a data structure, something like this, but we cannot see this. Okay, because visually we cannot see our memory content. Okay, but what we can do, we can display these values. We may display addresses of each node. Okay, we can insert a new value. We can delete a new node. A value means a node. We can delete a new node. Okay, deleting means just unlinking. So for instance, if you want to delete this, you want to delete this, remove this from a linked list. So what we'll do, just instead of pointing this here, So the second node to the third node, we will point second node to the fourth node. So that means this is delinked. This is no longer linked within our linked list, but still it will exist in our memory for some time. At least the program is running. Okay. Any question? Okay. So I like you to go through these chapters. Okay. So here are the main thing of a linked list. The main element of a linked list is a node class. So node, by saying node, two things, we will say the node class. No, actually a node object. So how do we declare an object? In order to declare an object, we know that we need to create a class first, right? So this is the node class. This is the node class we will be implementing. In our program. In our program, we'll be implementing a node class first. Okay. A node class contains some variables, okay, data fields, and another variable is called linked field. So linked field, a data field, data variable can be any valid type, but the linked field must be a node pointer. Node pointer. Why it is need to be node pointer? Because this link field is contained address of another node. It's address of another node. Okay. So this is why it needs to be, it must be of node type. What is node over here? The same node. The same node. The same node type over here, what we are creating. So it's kind of recursion. Okay. So you are declaring a node class and we are using the node class inside it. Okay. So usually these are private, declared as private. Okay, but you can make it private, but if you make it private, then there is this possibility of privacy loss. Okay, so we should make it private. So if we make it private, then we can use a special way, and then we will do that. Okay, so in a linked list, there are some, it's a terminologies, there are some common elements. One thing is this called header pointer and the tail pointer. Header pointer contains the address, okay, address of the first node in the linked list. Okay, and the tail pointer knows or holds or contains the address of the last node. So the names infer, right? Head means top and the tail means bottom. And we'll see that how do we traverse a linked list. We started from head and then go by one by one. Okay. So both header pointer and tail pointer, these are pointer variables. So this needs to be declared as pointer of what type? Of pointer of node type. Okay. Remember that this must be declared as pointer of node type. So declaration of pointer must be of node type. The node is class that we will be declaring. So sometime if we know that a pointer is an object. So if it does not contain any value, then it holds the null value. It's a null value. Default is null value. So that means this is a null value. If a pointer has null value, for instance here, then we say that this is the last node. This is the tail node. Okay. Otherwise, this is not null. This is not null. Okay. And if a head pointer is null, then what do you understand from here? Who can answer this question? I said that if tail pointer is null, that means that is the last node in the linked list. But what happens if the head pointer is null? What do you say?
If the head pointer is null, then it's an empty list.
Yes, you're correct. Thank you. So if the head pointer is null, that means we see that the linked list does not contain any element, any node. Yeah. Okay, good thing. So we will see that node class, it also contains constructor. We know that a constructor is used, okay, to create an object of a class, right? So constructor has same name exactly of its class name, and a constructor does not. A constructor is a method, definitely, and a constructor does not have a return type. Even you cannot say while, and it does not have a return statement. So here, now we are coming here to see that. This is a node class. Okay, so we will declare a node class. So how can I declare a node class? In a header file, we will say that node.header node.h file. Okay, and then you can say type diff command. You can use type diff command. It's optional, but is tradition. Type diff means you are defining an existing type by another name. Okay, that means here you say type diff value double equal to value type. So value type, later we will see that value type will be what kind? Is double kind. Here later we see instead of double we use value type. So here is constructor method. So constructor method, you see that it is a little bit complicated, but let us try to understand. Okay, so constructor constant keyword is used to value type, and this is ampersand initial data. It contains the initial data value. And how do we get the initial data value? By value type constructor. So value type actually it is defined within the C++ standard library file. And this is the value type method. This is value type constructor. Okay. And initially when we create a node, so then we create the node with empty leg. Okay, so the node it is as I said that a node contains two things, right? One is data value that is defined by the first statement, and another is address another is a pointer variable to hold the address of this, right? So this is the second part is the address of type node. Node, this is a pointer of linked list, and initially we put null. That means initially what it creates when we create a node object, sorry. Okay. So initially what value will be assigned over here, that value will take data value, and this one node, this type of node, that means it will be null initially. Will be null. Okay, and
I have a question.
yes.
I'm trying to understand why they use the const keyword then the value type reference in the constructor.
Okay. Thank you. So constant is used to so that it does not change. We cannot change this. Actually, we will see that there will be two types of nodes. Okay, one is this is constant means that we cannot change this value. The first one. We
So
cannot change.
once we set it in the constructor, it can no longer be changed.
Yes.
Okay, that makes sense.
We will come with an example, then we will understand this. Okay. So as I said that initially it is a little bit critical. Okay, then this statement is that they put in one line. So the data field is initialized by initial data, and the link field is initialized by linked data. Okay. So where are the data field and link field? Can you guess?
Pointers?
No. These are the private variables, private field of this data field and link field are the private variable for node class. So this book, I don't know their policy. I would, sorry. So this book, you see that they have given like this part at the end. It is okay as long as it is within class, it works. Okay, but I would usually want to put this here at the last, okay, at the beginning of the class. So if I would put this at the beginning of the class, you would not be confused. That's it. So data field, so a node, every node, as I said, that every node contains two things. One is data, and another is address of the next node. So in order to hold the data, we use data field. So that is data field over here. Okay, that is data field. This variable, we need variable for here. Okay, that is for data field, and another variable for here, that is a data link field. See that? So here this one data field comes from here. This data field comes from here. So imagine that these statements are at the beginning. So if it is at the beginning, you would not be confused. Okay, so data field is initiated with value with init data, and the link field it gets value with link initially init link. So initially init link equal to null. Okay. Now the node class, every node class contains a few other methods. Okay. For instance, the set data method it sets the data, and set link method, it sets the link. Okay, and how the set data method sets data. So these are the functions prototype. That means it takes, in order to set data, it takes a
Reference.
data, yes, reference. It takes a value. Okay, and then how do we set this data field equal to new data? Okay, so if you are familiar with Java, then it is better. This course are written with simply in Java and C#. But in C++, it is, these methods are defined with a little bit complicated. So because this is why it may be confusing at the beginning. Okay, but if you give attention, you see that data field equal to new data over here. How do we assign? And set links, this is the prototype set link method. It takes a node of link, and link field equal to new link. So here, this one, you see that almost we use this one right here already. Data field equal to unique data, and link field equal to init link. And these are for initial. Okay, so these statements are initial for the when you are creating a new node. But once when you are inserting data in a linked list, then we will use this method. We will use this method when we are building a data. Okay, so someone trying to present, to share your screen. You do not need to share your screen, okay, unless I ask. Yeah. And you see that value type is data. This is data is another this line. Okay, so here value type here is double. Instead of writing this complicated thing, you could say double over here, but the traditional in C++ they write this way. So data is another method, okay, that returns the data. So for instance, if we want to see what data I have for this node, so then which method I will use? I will use this data method. Okay. So instead of writing double over here, they use this way so that if in case you need to change the data type, just you will change one place over here. Then you do not need to go many places in your program to change the type. Just you will change in one type. So this is why they use value type in the inside. So this is the advantage of using type diff. In case in later we need to change, we will just change over here. For instance, if you want to create a linked list of only integer type, then we'll change only one place here. Instead of double, you will put int. In the entire program it will work. Otherwise, if they would put value type over here double, and everywhere if they would put double over here value type, then you need to change. You are supposed to change in many places, but it is convenient that you are changing in one place. Okay, so this is a general structure of the node class. So the node class is the main element in a linked list. Once you create a node class, then using this node class, you can create as many node objects you need. So for instance, Yeah, someone is trying to share your screen. You do not need to share your screen, please. Stop. Okay. So once you create a new node class, right? Once you create a node class, then we have created a node type, right? Then we can create many node objects. For instance, we can say node n1, n2, n3, n4, n5. Okay, so we have created 5 node objects over here. So then there will be 5 node objects. So n1, n2, n3, n4, n5. If we say that n1 is connected to n2, okay, we say n1 dot link n1's link equal to n2. That means n1 will be connected to n2. If we say n2 is linked with n3, then it will go this way. If we say n3, so this is n1, n1, n2, n3. And if we say n3 is linked with n4, so maybe n4. And then say n4 is linked with n5. And then as we know that every node initially we create a data field and an address field. Data, address, data, address, data, address. So the last, initially by default, all nodes are created with null value in the address field. So what will happen that, so this one will be null, or in some books you will see the cross sign over here. Cross signs means that this is the last node. And later, okay, so then one more thing is that we need to understand. So in addition to this node class, so that means once we create a node class, then we will see that only we need to write very one line of code in addition to this. Definitely we will write this in main method. Okay, so we will write this within main method. And within main method we create a node object, and then we will see, we will define n1 points to n2 like this way. So that means n1 points to n2. That means n1 is connected to n2. So then we will see, okay, so it is okay, we need to put set link n2 and on set link n2 this way. So we have already methods. So this is why for now just give attention for the link node class, because the node class is the main element of a linked list. Once you understand the node class, then it is easy to do that. And one more thing that we have left, need an addition, we need a head pointer. The head pointer will tell us which is the beginning of our linked list, which node is the top node in the linked list. That the head will tell us. Okay. So in our in D2L, if you go to D2L, then you will see that chapter 5, it has linked list, this PowerPoint presentation. Okay, have already downloaded the PowerPoint. Let me get it. Chapter 5. Why is it? Chapter 5. Chapter 5. Okay, this one. Did I take this one? Okay. So this is the PowerPoint from our D2L. So let us go to the slides now, whatever we discussed from the book. So as you see that in the next, so as we said that a linked list, okay, is a dynamic array. It can be declared is a dynamic list. It can be declared as using a static or dynamic array, but usually a linked list is implemented with the dynamic array, and it can hold any data type. So this is a traditional array. The left side is a traditional array. How do we use a traditional array? How memory are allocated in traditional array? Memory spaces are allocated in traditional array, consecutive memory space, right? But in linked list, okay, memory spaces are allocated randomly. So you do not need to have consecutive memory locations in free memory location. So wherever nodes can get memory position, it takes place over there. And what it only knows, where is the next address. Okay. For instance, if you have some friends and then or family members in our life, for instance, we have friends or family members, right? We do not need to live together in the same community or say in a row house, right? If we know our next relative address, then I can go there in a nearby community or a nearby city or a nearby state or anywhere in this world. As long as we know that we have a relative and we know the relative's address. So it is not required that all of your relatives will live in same place, same city, same area together. So in a traditional linked list is a concept that all of your friends or family members are living together in the same community. But in linked list concept is that you don't need to stay together. You can live anywhere as long as you know each other address and you are connected with each other. Okay, you can communicate with them. So this is the concept of linked list in daily life. Okay, so a linked list is the main thing is that we discussed that head nodes, right? So node are the main thing, main ingredient or element of a linked list. Okay, so this is all of this. This is a node. So this is a node. This is a node. This is a node. And as we saw that a node contains two things: address and the data and address of the next node. So this is how, by knowing the address of the next node, each node is linked or connected with another node. Okay. So the last node is called the tail node that has empty. So for instance, this does not have any symbols, but in some books or in some places you may see that this the last node is linked as like this. Is denoted as this. This cross means that it is the tail node and it has the link address is null. That means it is not associated, it does not, it is the last node. It does not have any more link. And the head, it is the first node. It is the first node address. So every linked list has a head. Every linked list has a head. Okay. So like it is a kind of an ideal society. So for instance, if we live in, many of us will live in a gated community, right? Is anyone here that live in a gated community or like a what is that called? An apartment complex or in a dorm?
Yeah, I live in an apartment with a gate.
Okay, that's good. So let us think about a gated community. Okay, an ideal gated community. How an ideal gated community be? For instance, each household member will know who are other people living in this community, right? If you live in a community, especially in a gated community for a long time, you should know who is your neighbor, right? You should know who is your next neighbor, who is the next neighbor, next neighbor. You should know at least 5, 10, 20 your neighbor household members. They're your friends or neighbors. Or at least you should know one members or two members who is the left side or front of you and who is right side or back of you, right? In an ideal society, you should know. Okay, or at least one, you should know at least who is next to you or who is in front of you, right? So in a gated community, think about is a gated community. Each of these node is a house. Each of these node is a house. So a node can be any kind. It can be a house, it can be an apartment, it can be a room. So an object. Object can be any type, right? So in a linked list, every node knows that who is the head. So in a community, or is it gated community, there is a head, chief, in the community, okay? So the head knows who is the starting. Head is the starting node. Maybe the very first apartment holder or householder at the gate, near to the gate. And then if someone asks one to know, hey, where is John living? Then he will go to the node, head. Okay, and head will know, okay, who is the next to him, who is the next to him, who is the next to him. Everybody will know who is the next to him. So then head will say, where is John living? Then head will ask the next person, hey, are you John? Or do you know who is John? And the next person, if the next person is John, then he will say, reply, hey, yes, I am John. Or he will say, no, I don't know who is John, but I'm going to my next neighbor. I'm asking him whether he's John or he knows John. So the next person, next node, will do same thing. If he is John, then he will reply, hey, yes, I am John. Or if he is not, then he will say, hey, I'm not John, but I can help you by asking my neighbor, next neighbor, whether he is John or he knows John, who is John. By this way, the community, the searching will start from the beginning and go one by one, all the way end. So if there exists a John in this community, in this linked list, then it will, John will reply to his previous node, and he will reply to his previous node, he will reply to his previous node, and he will reply to head, and he can say John's position is 5th in the linked list, or he does not exist. Okay. So this is the way that a linked list works, searching node by node. But we can sometimes jump from here to here but that is not usually done. Usually it is done, it is not done usually. So it is done from one to here, here to here, here to here, and one by one step at a time. So whenever you are getting up on a stairway, right? You usually step on each step. You may skip a step and go to the next step, but you usually do not do it, right? You may fall down, it may twist your legs, or you may get trouble. So we do not do that usually. Okay, so this is in tradition. Okay. So every linked list has a head and a tail. Head will be the first node and tail will be the last node. Okay. And as we discussed that, what is a node? A node is an object of a node class. Okay. So the main, so by telling in linked list, stack and queue, we will first come up with a node. The same node we will use for linked list, stack and queue. So what does a node contain? A node contains two things. Some data field, it can be one data, it can have multiple data fields. Okay, it can have name, only name, or name, ID, email address, addresses, physical addresses, many things, and only one link field. Okay, so this is a traditional node anywhere. So a traditional node, it will have data and the link field. Except the last node is different. The last node contains null value. Okay, in a book, sometimes you see the cross sign. Cross means that is the last one. It contains the null value. That is the boundary. It does not have any more node connected. Okay, so this is, you see that the first node and all other nodes is link field except the last node. So data fields are used to store data. It can be any valid data type. And link field are store the memory address of the next node. So it must be pointer type. Okay. Okay, this slide, it has the public type define command and then two variables. One is two fields. One is data field, another is link field. So data field will hold the data and link field will hold the address. And in addition to these fields, it will have some extra methods. One of the methods will be constructor method, the node constructor method. Another will set data, link data, and link. These are the four. 1, 2, 3, 4, 5. At least 5 methods you will have in a linked list in a node class. You may have multiple constructors. At least 5. So this constructor function is used to finalize the data field with default value of the data type and link field, and the link field is set up with value null. So that means whenever we create a node, its link field is initially or by default set as null. Okay, so far does anyone has any question? Do you have any question? We have 18 people. So is everybody good?
Yeah, so far so good.
Okay. Now let us see that how the linked list works. So for instance, the data field of each node is a type called value type, and that is defined by typedef command. So here this one. So as I said, that the advantage of using typedef command is that we are defining our type only once, and if we need to change our type, so we can just change it by changing in one place, and that should work. Okay. And it contains the pointer to the next node. You see that this is the all of this. This is a node. This is another node. This is another node. The first node contain value 10, and it contains the link field. So link field, it is the address of this next node. So we do not see the address usually unless we retry. We do not see it. Okay, and then this second node, this is the third node. The second node is connected with third node, and third node has the link. The last node is link field is null. That means it is the last node. It is not connected with anymore. So in this picture, in this figure, do you realize anything missing? There is something missing over here. Do you understand what is that missing?
The head pointer?
Yes. So in a, I said that in linked list is more likely as a gated community. In an ideal community, there should be a community leader or community head, right? The community head will tell us which is the beginning of linked list. What is the starting point of linked list? Because in the linked list, we will not see actual this arrow. Arrow is given over here for visualization. But in actual program, we will not see here any arrow. Not see any arrow. You cannot draw an arrow. So the head is missing. Okay. So it does not say which one is head. So apparently, by looking, if you understand the arrow sign and what does this arrow mean, so then we know that this arrow is mean the connection. Then you will guess that this is the head. Number 10, not number 10 is the head. So there should be an arrow over here. That is the head. So head pointer. So head pointer was missing over here. Okay, good catch. Now this is the constructor. Okay, node constructor function method. So these are the same thing from the book. I just a few minutes ago opened the book. Okay, these are the same thing. So data field, data content can be anything. It can be integer, it can be float, it can be double, it can be string or any type. Okay, and the data value type, this is constructors. So you see the method, it gives the default value of data types. So then you do not need to give the default value. For integer type, default value is 0. For float type, default value is 0.0. For boolean, default value is false. For character type, boolean default value is \0. So but if you use this one, then you do not need to assign default value, so it will work automatically. C compiler will get it. Okay, so this is why it is, so this constructor is constants means this type, it initially it will take the initial default value. Okay. Okay, and data field will be, the data field is the field will be initialized with initial this value, init data, and linked field will hold the link, init link. Okay, there is a typo over here. There's a typo here, I'm sorry. This let me clear it. This semicolon should not be here. This semicolon. No semicolon. Okay. Just get rid of this semicolon. Okay, and the other methods, it is just retrieved from this space. Okay, from this space. Set data method, set link method, data, and then link. Okay, and we see that the two links method, one is called constant pointer, and another is for traditional pointer, ordinary pointer. We will discuss this, but keep in note that there are two kinds of links method. Okay, one is with constant and another is traditional non-constant. Okay. So the constant version returns a constant pointer such that the pointer cannot be used to make changes to the node it points to. Okay, but if we want to change, if the ordinary version of the node method returns a ordinary pointer that is receiving the context that can make change of a node object using the return pointer. We will see this use, but for now just remember that the link method has two variations. One is constant, another is ordinary. And here this is minus and then arrow. This sign is equivalent to Java and like C# and Python's dot operator. Okay, that means off. In C++ we use arrows. This is called arrow operator. Okay, for instance, we say p arrow of data. That means we are calling this data method, okay, for the pointer p. Okay, but that it can be written in two ways. It can be written in p. So it's p, then star p, that is star p, that is an address, right? A pointer, and then dot. So if you use this way, then you must use dot operator, because dot operator has higher precedence than star. Okay, that means higher precedence than the pointer operator. That means if you do not give this parenthesis, then it will not be executed fast. So dot will be executed fast. So the program will get an error. Okay. So remember, we will use this arrow operator. So look at this screen, okay? So if you understand this screen, then we are done for today. Okay, for instance, here n1 equal to new node. We are making a node. N1 is a new node, N2 is another node, N3 is another node. Okay, but what we are doing over here, N1 is making a node. That means this node is getting what value? Is getting default value. What is a default value for node? So this node, if this node it takes integer type, the default value is 0, and by default it takes link, initial link is null. So that this node will have value 0 and then link is null. Do you understand why the link is null? Because initially, let us go back to here. Consider initially a node, it takes its default type, and default value. Default value is for integer type, default value is null. Default value is 0. Okay, so this is get default value 0, and then null initially it takes null, that is not linked yet with another node. And then N2 is now if you give a default value node, then it is given a value, then it is getting value 2.5. Now it is no longer taking the default value, it is taking default value as 2.5. And what is the link? Link is null. Still there is, you have not assigned any link, so link is, it is not linked with anyone, so link is, this is only single node. And but for this one, N3 equal to new node, value is taking 5 and it is getting linked with N2. Okay, so that means N3 is linked with N2. Okay, and here another way, how can you set data? For instance, here N1 is your initial data is 0. But you now if you want to use is set a data for instance 10.0 instead of there is a typo over here, it should be 0.0. So for double type it is 0.0. Actually this should be 0.0. Okay, now if you use this one, then set value will be 10. Data value will be 10 and linked address is null. And now if we use this address, this statement, so n2 dot set link equal to n1. So n2 will be linked with n1. So that means the link of n2 is the address of n1. Link 2 will contain the address of n1. And now if you see out the n1, n2 data, so what is the n2 data? N3 data is 5. So N3 data is 5, it will be 2. So the output will be something like this. Okay. Does anyone any question about this?
No, sir.
Okay, so please read these slides. And then you will see that there are some common linked operations. We will go through this operation in our next lecture and with a live program code. Okay, so live program code, that means in the book. So please, so book says what is that? 5.2 section 5.2. But this is 5.4. So 5.2.
Would you recommend rereading chapters for preparation for the test? Would you recommend rereading the chapters for preparation for?
Yes, for the test, you have to read the chapters. Please read the chapters for the test. Okay.
Got it. Thank you.
And I will see that if there is a study guide for the for other sections, I will post that. Okay. So this is the method we will go to our next lecture. But in order to understand this Please read the chapters and until 5.2. So in the 5.2, whatever you understand, even be clear about 5.1. Okay, that whatever we discussed so far. In 5.2, we will see that we will discuss. So we already discussed these things. In 5.2 is just the implementation of a program. Okay. So go through as long as you understand. If you do not understand anything, then ask me a question and we'll discuss. And then in the next lecture, we will go through actual live code. How we will see, we will implement this language live program. And in D2L, you see that if you open in D2L, that there are some files. Okay, so download these files. Okay, download these files. Some of these are completed, some of these are semi-completed. And try with this thing, then we will see that if we understand something. In our next lecture, we will go through this. Okay. Does anyone has any question?
No, sir.
Okay. Thank you so much, and you have a good day.
Thank you. Have a good day.
Bye-bye.